The International Space Station, our most iconic space laboratory, is collapsing much faster than expected. Cracks are spreading, leaks are worsening, and the Russian modules are literally aging out of service. Yet inside, cutting-edge experiments, rare gear, decades of global cooperation. And we might deorbit it all within the next few years. Elon Musk thinks it's time to shut it down. NASA has a plan. SpaceX is preparing a Dragon variant to deorbit the station. But are we ready to lose everything on board just to move on? In today's TechMap episode, we break down the latest ISS crisis, Musk's explosive statement, and what it means for the future of space stations and space science itself. Strap in. The space race is shifting gears, and this might be the last chapter of the ISS as we know it. Let's dive in. Axiom 4 is now scheduled no earlier than Thursday, June 19th, after getting delayed on June 12th, when NASA and Roscosmos continued to understand the most recent repair efforts to seal small leaks on the Russian side of the International Space Station. The leak happened because parts of the space station's metal structure, especially in the Russian section, have been getting weaker over time. This happens because the metal is bent and stressed again and again as the station orbits Earth. When metal is bent many times, it gets tired. This is called metal fatigue. Imagine bending a paperclip back and forth. At first, it's strong, but if you keep bending it, it gets stiff and eventually cracks and breaks. The same thing happens with the aluminum metal on the ISS, the metal it's made of. Tiny cracks start to form, and over time, these cracks get bigger until the metal can no longer hold the air inside, causing leaks. This process is called high cycle fatigue, meaning the metal has been bent and stressed many times, thousands or millions of times, making it weaker and more likely to crack suddenly without warning. Since the ISS has been in space for almost 30 years, this repeated bending and stress have caused more cracks and leaks than people first thought. So the leak is caused by the metal getting tired and cracked from bending and stress over a long time, just like a paperclip breaking after being bent too much. Additionally, space has no air to cushion things, and the temperature swings from super hot to super cold, which wears out materials faster. The gas leaks are located in the transfer tunnel, called PRK, a tunnel connecting the Russian Zvezda module to a docking port. Zvezda is one of the oldest components of the ISS complex, with the first components launched in 1998. The station has had a slow but growing leak since 2019. Russian cosmonauts have attempted to repair these small cracks, but they typically only slow the leak with gas loss of a few pounds per day. According to Axiom Space, as part of an ongoing investigation, NASA was working with Roscosmos to understand a new pressure signature. Cosmonauts aboard the space station recently performed inspections of the pressurized module's interior surfaces, sealed some additional areas of interest, and measured the current leak rate. Following this effort, pressure in the transfer tunnel has been stable. The postponement of Axiom Mission 4 provides additional time for NASA and Roscosmos to evaluate the situation and determine whether any additional troubleshooting is necessary. Some people familiar with the situation are offering little information about the severity of the situation. However, on X, Casey Hanmer, a smart guy who knows a lot about space, raises the red warnings. As he said, there is no factor of safety associated with this failure mode. None of the structural pressure vessels are meant to crack. We are not even single fault tolerant on the structural integrity of the station. Normally, things like buildings or bridges are built with extra strength to handle problems. But the ISS wasn't designed to handle cracks, so if they get bad, it could be dangerous. He added, "We could wake up tomorrow and find, with zero warning, that it has failed catastrophically. Whether that means a leak slow enough to close some hatches, get the crew out, or at least into safer parts of the station, is a roll of the dice. It could also depressurize in less than a minute. Well, if the cracks get too big, air could leak out fast. This might give the astronauts only a minute to close doors and get to safety. Or it could be even worse if they can't fix it in time. So right now, it's basically a race against time to see whether NASA and Roscosmos can fix the issues, or if the Russian segment of the space station might have to be shut down entirely. There's been a lot of chatter online, with some people thinking they could patch up the cracks or replace the damaged parts. And of course, the internet being the internet, some folks joked about slapping on some flex tape. You know, that super strong stuff from the TV commercials. But let's be real, that's definitely not a serious solution. If the damage turns out to be too severe, the only real option might be to seal off the Russian module, or in a worst-case scenario, shut down the entire ISS. The station's getting pretty old and worn out anyway. And with the rising tensions between the US and Russia, it's hard to see the ISS as the shining symbol of global cooperation it once was. SpaceX's CEO, Elon Musk, seems to echo my thoughts in a recent tweet. There are potentially serious concerns about the long-term safety of the space station. Some parts of it are simply getting too old, and obviously that risk grows over time. Even though SpaceX earns billions of dollars from transporting astronauts and cargo to the ISS, I nonetheless would like to go on record recommending that it be deorbited within 2 years. This isn't the first time Musk has raised alarms about deorbiting the ISS. So why the urgency? For starters, safety is a major concern. The station is aging, and with every passing year, the risks only grow. Then there's the money. Running the ISS costs around $3 to $4 billion per year, a hefty sum even for a spacefaring nation. Musk likely sees this as an unsustainable burn rate. Pulling the plug early could free up billions for SpaceX's bigger ambitions, like building a permanent presence on Mars, a goal that's been central to his vision from day one. Now, even though SpaceX makes a fortune ferrying people and supplies to the ISS, Musk's readiness to walk away from that revenue shows he's thinking long-term. He's betting that building new, next-gen space infrastructure will pay off far more than clinging to an aging orbiting lab. By ending ISS involvement, SpaceX can reinvest its over $10 billion yearly revenue, previously split between ISS work and other projects, into pioneering ventures. But it's not just about hardware or dollars, it's political too. The ISS is a joint effort between NASA, Roscosmos, ESA, JAXA, and CSA. Yet with tensions flaring, especially after Russia's actions in Ukraine and recent mystery leaks on the station, the alliance is showing cracks. Musk may simply want to end the dependence and move on. Russia, for its part, is already planning its own independent orbital station, targeting a 2027 launch for the first module and full completion by 2033. And then there's the bigger picture. SpaceX in 2024 secured an $843 million NASA contract to build a Dragon variant, which is capable of safely deorbiting the ISS. For Musk, this isn't just a job, it's a chance to lead the shift toward privately operated stations. His stance on scrapping the ISS reflects a clear belief. It's better to start fresh with modern Starship-based solutions than try to patch up the past. Ultimately, it all ties back to Musk's core dream, settling Mars. The ISS, while valuable, diverts time, talent, and money from that mission. Taking it down sooner rather than later helps clear the way for faster progress on Starship, lunar missions, and beyond. So, what does NASA think about Musk's viewpoint? In an official statement, NASA said, "In the future, the United States plans to transition its operations in low Earth orbit to commercially owned and operated destinations to ensure continued access to essential research and technology development." At the conclusion of the International Space Station program, the station will be deorbited in a controlled manner to ensure avoidance of populated areas on Earth. The station's safe deorbit is the shared responsibility of the 5 space agencies. As of now, there's no sign that NASA plans to walk back its commitment to keep the ISS running until 2030. Of course, deorbiting the ISS doesn't look like a walk in the park. Let's be real. This is a tightrope walk. The commercial space stations like Axiom Station and Blue Origin's orbital reef are getting delayed. Starship needs tweaks. And coordinating with global partners is a headache. The ISS has gear and experiments worth salvaging. Are we ready to lose that? And what if Starship's not up to snuff by 2027? Elon's known for tight deadlines. Think Falcon 9's rapid rise. But this is next level. Fans on X are split. Some love the boldness, others say it's reckless. What do you think? Drop your thoughts in the comments. Anyway, if you love this deep dive, smash that like button. Hit subscribe and ring the bell. We're aiming for 150,000 subscribers, and we need you to get there. Check out our other videos on Starship, Artemis, and more. And let's keep exploring the cosmos together. Looking ahead, Elon's dreaming big. His X posts suggest a SpaceX-built successor, maybe a spinning habitat or a lunar gateway. Starship, with its demonstrated cargo capacity, could transport lab modules or crew to temporary orbital platforms or lunar gateways, maintaining scientific continuity. This aligns with SpaceX's roadmap, which includes lunar Starship missions as early as mid-2027. Fans even threw in Fifth Element cruise ship vibes. With NASA's deorbit contract and Starship's potential, SpaceX could lead the post-ISS era. But it's a gamble. Success means a new space age. Failure could leave us grounded. Either way, it's a wild ride. All right, space cadets, that's the scoop. Elon Musk is pushing to deorbit the ISS by 2027, with SpaceX leading the charge. Love it or hate it, it's a game changer. So, what's your take? Do you prefer this idea? Again, feel free to share your thoughts in the comments section below. The space station was officially given approval by President Reagan, and a budget was approved by the U.S. Congress in 1984. NASA Administrator James Beggs sought international partners, including Canada, Japan, and the European Space Agency, ESA. The station design phase lasted from 1984 to 1993. Construction of elements began in the late 1980s across the US, Canada, Japan, and Europe. By 1993, Russia was invited to join during a redesign phase. Agreement to proceed in two phases. Phase 1, NASA Mir, 1995 to 1998. Shuttle missions docked with the Russian Mir station. The U.S. helped modify Russian modules, Spectre and Priroda to house U.S. experiments and astronauts. Phase 2, from 1998. Launch and assembly of the new ISS with contributions from all partners. Despite the arrival of new CEO Kelly Ortberg on August 8, 2024, Boeing's troubles are far from over. Just a year after the tragic 737 MAX disasters, the spotlight has now shifted to the 787-8 Dreamliner. On June 12, at exactly noon, tragedy struck again. Air India's Boeing 787 Dreamliner, Flight AI-171, crashed shortly after takeoff from Ahmedabad Airport in Gujarat, India. The crash claimed 241 lives, with just one survivor, a heartbreaking disaster that sent shockwaves through the aviation world. What makes this incident even more chilling is that the 787 Dreamliner has long been celebrated as the world's safest commercial aircraft. Introduced in 2009, the 787-8 variant was even touted by Boeing as the best-selling wide-body passenger aircraft of all time. For such a highly regarded aircraft to suffer its first fatal crash now raises unsettling questions. If even the safest plane isn't safe, where can passengers place their trust? While investigators are still determining the cause, the crash reignited past warnings. A former Boeing engineer had previously raised alarms about improper assembly of fuselage components, warnings that were publicly dismissed by both Boeing and the FAA, who maintained the aircraft posed no safety risk. But public trust is wavering. Whistleblower Sam Salahpour, a Boeing quality engineer, alleged that the company had cut corners during manufacturing, compromising the plane's long-term structural integrity. He claimed to have witnessed workers jumping on parts to force alignment, and said he faced retaliation for speaking out. Even more disturbing, another whistleblower, John Barnett, tragically died by suicide in March 2024 amid an ongoing lawsuit against Boeing, further fueling suspicion and public outrage. According to the Aviation Safety Network, the 787 Dreamliner has experienced 291 significant and minor incidents before June 12th. The aircraft was grounded twice due to various problems, including lithium-ion battery fires, fuel leaks, cabin pressure malfunctions, and software errors. This recent crash is another devastating blow for Boeing, a company already grappling with crisis after crisis. On June 12th, Boeing's stock plummeted 5 to 7%, and its suppliers also faced sharp market criticism. This follows a 25% stock drop in 2024 after another alarming event. A 737 MAX operated by United Airlines lost a wheel mid-flight and experienced engine fires. Boeing's financial report for 2024 revealed a staggering $11.8 billion loss, bringing total losses since 2019 to over $35 billion. The financial fallout also saw CEO Dave Calhoun step down at the end of the year, leaving behind a mess for his successor, and walking away with a controversial golden parachute estimated at $24 to $45 million. What all these points point to is more than just bad luck or isolated errors. Former employees and aviation regulators suggest a deeper, more systemic issue. A corporate culture that favors speed and profit over passenger safety. And while Boeing insists it's committed to reform, the recurring nature of these failures raises serious concerns about whether those problems are rooted in the very fabric of the company. Bear in mind, it's not just Boeing's commercial planes that are raising eyebrows. Major problems are also surfacing in its aerospace division, which also plays a massive role in the company's revenue and long-term strategy. Take, for example, the long-troubled Starliner spacecraft. Initiated in 2014 under NASA's Commercial Crew Program, with a $4.2 billion fixed-price contract, Calypso has spent over a decade battling a string of technical failures, ballooning costs by more than $2 billion, and damaging Boeing's reputation in spaceflight. The trouble began early. During the first uncrewed orbital flight test in December 2019, a serious software glitch set the internal clock 11 hours off, causing the thrusters to fire at the wrong times and preventing the capsule from docking with the International Space Station. Another software flaw, this time a valve mapping error, posed a real danger during re-entry, potentially causing the service module to collide with the crew capsule. Although ground teams managed to avert disaster, Boeing had to recheck more than 1 million lines of code, exposing deep flaws in its software development process. When Boeing launched its second uncrewed test flight in May 2022, the spacecraft encountered thruster failures during orbit insertion. Backup systems saved the mission and allowed for a successful docking with the ISS, but post-flight reviews revealed even more issues. Faulty valves in the propellant system, fire-prone tape on wiring harnesses, and parachute connectors that couldn't withstand the required stress loads. These problems delayed the long-awaited crewed mission even further. Finally, on June 5, 2024, the first crewed mission, dubbed the Crew Flight Test, lifted off with NASA astronauts Butch Wilmore and Suni Williams on board. But the mission was anything but smooth. 5 out of 28 reaction control thrusters failed as the spacecraft approached the ISS, delaying docking by nearly an hour. Investigations showed that the Teflon seals inside the thrusters expanded under heat, choking off propellant flow. Meanwhile, 5 helium leaks, originally dismissed as minor, grew into a serious threat, compromising the entire propulsion system. Despite a hot fire test in July that suggested most thrusters were performing within expectations, concerns about re-entry safety lingered. NASA ultimately ruled that Starliner was not safe enough to bring the astronauts home. The capsule returned without a crew on September 6, 2024, and brought new issues with it, including a thruster failure and a guidance system blackout during re-entry. Over the last 10 years, Starliner has suffered from nearly every technical issue imaginable: software bugs, thruster malfunctions, helium leaks, valve corrosion, documented as early as 2021, parachute defects, and structural weaknesses. These setbacks point to something bigger than bad luck. They reveal systemic flaws in Boeing's development practices. Anyway, if you loved this deep dive, smash that like button, hit subscribe, and ring the bell. We're aiming for 150,000 subscribers, and we need you to get there. Check out our other videos on Starship, Artemis, and more, and let's keep exploring the cosmos together. However, we all know that the biggest elephant in the room here is always greed. If it weren't for greed, how else do you explain Boeing's stumble the moment NASA shifted to fixed-price contracts under programs like the Commercial Crew Program? For decades, NASA relied on cost-plus award fee and other cost-reimbursable contracts. These were a dream for legacy contractors like Boeing. Just look at NASA's Space Launch System program, where Boeing is the main contractor for both the core stage and the exploration upper stage. Under these traditional agreements, the government bears the financial risk. If technical challenges or delays push costs higher, Boeing still gets reimbursed. No sweat off their back. We don't know exactly how much Boeing has been reimbursed, but we do know this. The initial 2017 budget for the EUS was $962 million. That number has ballooned to around $2.8 billion, expected through 2028. The total cost for Boeing's SLS work has far surpassed original estimates, with the core stage alone costing nearly double its initial projection. And then there's the wasted time. The SLS was supposed to launch in December 2016. It didn't fly until 2022, more than 6 years late. The EUS delivery has slipped from February 2021 to April 2027. Artemis 4, which relies on the upgraded Block 1B SLS with the EUS, is now penciled in for 2028. That's years behind schedule. Now compare that with fixed-price contracts, which shift the risk to the contractor and prevent them from passing the bill to taxpayers. And guess what? These contracts are also exposing Boeing's internal issues: poor planning, weak oversight, and sloppy execution. From substandard welding and fuel tank contamination to submitting damaged parts for inspection, the problems keep piling up. Worse, NASA's lax oversight has allowed these issues to escalate from cost overruns to actual human risk, as seen in Starliner's troubled first crewed flight. NASA likely saw the signs early on. Boeing's greed was clear from the beginning of the Commercial Crew Program. Banking on its long history with NASA, stretching back to Saturn V and the ISS, Boeing lobbied hard for a sole source contract, aiming to lock in the entire $6.8 billion budget for itself. Confident in its legacy and eager to maintain the generous margins of cost-plus contracts, Boeing pushed to eliminate competition. And some within NASA were on board. Internal documents show efforts to justify handing Boeing the full award, citing its safety record and deep experience. But NASA's human exploration chief, William H. Gerstenmaier, pushed back. He insisted on competition, and won. In 2014, NASA awarded fixed-price contracts to both Boeing and SpaceX. That decision exposed a deeper truth. Boeing's approach was rooted in risk aversion and profit protection, not innovation. And once forced to play by the new rules, Boeing floundered. Meanwhile, SpaceX, with less money, launched its first crewed mission in 2020 and has been flying smoothly ever since. Boeing's early lobbying also reveals a critical misstep. The company assumed its past achievements guaranteed future dominance. But the competitive fixed-price landscape proved unforgiving. That overconfidence, fueled by a desire to preserve control and cash flow, may have laid the groundwork for Boeing's current crisis. from the Starliner crew being stranded in 2024 to the fatal Dreamliner crash in 2025. In the end, Boeing's greed-driven strategies didn't just fall short, they've triggered a much deeper reckoning. The public is now questioning whether Boeing still deserves a place in the future of space and air travel. That question is growing louder, especially as NASA eyes yet another Starliner launch, tentatively planned for early 2026. But everything about the mission remains up in the air, including whether it will carry astronauts or simply cargo. What's more troubling is that the National Space Agency still hasn't provided clear answers about what went wrong with the vehicle or how those issues will be resolved. All they've said so far is the agency is still evaluating whether Starliner's next flight will be in a crew or cargo configuration, and NASA continues to review its forward plans and execute testing campaigns targeted throughout the spring and summer. This carefully worded vagueness appears to be part of NASA's broader strategy to maintain redundancy in crewed spaceflight. That goal has taken on new urgency in light of the political tension brewing between SpaceX CEO Elon Musk and President Donald Trump. NASA seems to want a backup option, just in case the private sector becomes politically unpredictable. But considering Boeing's ongoing technical failures and reliability issues, maybe it's time for NASA to cut its losses and look elsewhere. Several promising players are emerging in the commercial spaceflight scene. Rocket Lab, Stoke Space, Sierra Space, and Blue Origin are just a few names in the mix. These companies are agile, innovative, and not weighed down by the same legacy baggage. And they might just offer NASA the dependable alternatives it so desperately needs. Rocketry is far from a walk in the park, especially for private companies looking to turn a profit by launching rockets. The hurdles are massive and come down to two major factors: technical challenges and financial pressure. Let's start with the tech side. Building rockets is insanely complex. Everything has to work perfectly. Just one small error can cause the whole thing to blow up. And when a rocket explodes, it's not just a spectacular failure. It's also a multi-million-dollar loss that sends shivers down investors' spines. On top of that, launching rockets requires specialized infrastructure, which costs a fortune. Then there's the environment these machines operate in. Rocket engines reach extreme temperatures and must survive the harsh conditions of space. Finding materials that can withstand this is no easy task. Many of these components are rare or hard to source, leading to delays or skyrocketing costs. Now imagine trying to push boundaries in this already punishing field. That's what visionaries are doing, challenging the status quo. NASA, for example, struggled with its partially reusable space shuttle and eventually returned to disposable rockets. Meanwhile, companies like SpaceX are doubling down on reusable systems to cut costs. But making a rocket safe and reliable for multiple flights? That's a massive engineering puzzle. On top of all that, the legal and regulatory side of things is a maze. If you're partnering with NASA or other governments, there's a rule book you have to follow. And space debris? Yeah, companies are now being held accountable for cleaning up after themselves. Think of it like an environmental tax for space. So, how do you stay afloat in this brutal industry? You need serious financial muscle. Most rocket startups are either backed by billionaires or rely on deep-pocketed investors and partners. And raising that money is just the beginning. Staying in the game long-term requires a sharp business strategy. And that's where diversification comes in. Rather than betting everything on rocket launches, private space firms are branching out. They're moving into satellite communications, space tourism, in-orbit servicing, building space stations, exploring the moon, you name it. This diversification often means developing cutting-edge tech like reusable rockets, space planes, or even in-orbit manufacturing facilities. Business models are evolving too, with ideas like point-to-point space travel and commercial space stations becoming serious plays. On the business side, Many of these companies also pursue both government and commercial contracts. This mix brings in stable government money while keeping innovation moving fast through commercial work. And if we're talking about pioneers, look no further than SpaceX. Their Starlink satellite network has become a financial powerhouse, helping fund the incredibly ambitious Starship program. And that's just the civil side. On the defense end, they've rolled out Starshield, a secure comms network designed for military and intelligence use. Starshield is one of many Department of Defense contracts they've landed. This strategy of straddling civil, commercial, and defense markets gives SpaceX a diversified revenue stream and a unique edge in the space race. Plus, they've got plans for space tourism with their Crew Dragon spacecraft, and even Earth-to-Earth travel via Starship. And the payoff is so sweet. Elon Musk claims that SpaceX's commercial revenue will surpass NASA's entire budget by 2026. And while that sounds wild, another space player is making waves on a similar path. Meet Sierra Space, a company just 4 years old, already known for its eye-catching Dream Chaser space plane. It's on track to resupply the ISS under NASA's Commercial Resupply Services 2 contract, but now they're stepping into defense, echoing SpaceX's transition from scrappy startup to aerospace powerhouse. On June 11th, Sierra Space unveiled its new Victory Works facility in Centennial, Colorado. This 60,000 square foot addition is supercharging production of their Eclipse satellite bus, a key piece for the U.S. Space Development Agency's missile warning systems. Backed by a $1.5 billion contract portfolio, this marks a serious shift. In fact, they recently landed a $740 million contract for 18 satellites loaded with next-gen fire control sensors. That's not just tech speak, it's a crucial upgrade to America's missile defense. This pivot to defense comes at a time when the 2024 U.S. Space Force report is emphasizing the urgent need for rapid satellite deployment in response to global threats. And Sierra Space isn't stopping there. Through NASA's Next Step 2 Appendix R program, they're exploring how to use expandable space station tech, like their Life habitat, for lunar logistics, including tunnel networks, cargo storage, and the infrastructure for a permanent moon base. All part of NASA's Grand Moon to Mars vision. And there's more. Dream Chaser isn't just a delivery vehicle, it's also conducting microgravity experiments, like 3D printing protein crystals for pharma giant Merck. The goal? Unlocking new possibilities in cancer treatment by making drugs more precise and effective. If that's not future forward, what is? Dream Chaser, with some unique advantages, will be the key to unlocking a future that some say even SpaceX cannot deliver. Dream Chaser stands out for its airplane-style reusability. Most capsules, like SpaceX's, splash down at sea or land in a few spots. Dream Chaser? It lands like a regular jet on standard runways around the globe. No massive Mechazilla launch towers required. That means quicker turnarounds, lower infrastructure costs, and faster access to whatever it brings back, be it astronauts, sensitive cargo, or emergency supplies. Flexibility is the name of the game. Dream Chaser can haul crew, cargo, perform satellite servicing, do science in orbit, and even assist with Earth observation. It's basically the space version of a Swiss Army knife. Plus, it's rocket agnostic. It can fly atop multiple launch systems, making mission planning more versatile and resilient. And here's a big plus. Unlike some spacecraft that rely on hazardous fuels, Dream Chaser uses non-toxic propellants. That makes it airport-friendly and lowers operational costs. Oh, and remember SpaceX's vision for point-to-point travel on Earth. Sierra Space is chasing the same goal: ultra-fast global cargo delivery using spaceflight. Think military supplies or disaster aid delivered in just hours. Game changer. Dream Chaser can also remain docked at the ISS for plus to 210 days, just like SpaceX's Dragon. And it's upgradable to survive harsh radiation, meaning it's ready for extended military ops. Safety? covered. In a launch emergency, it can autonomously abort and land safely on a nearby runway. No ground control needed. Sure, it has limitations, mainly a smaller payload compared to Falcon, New Glenn, or Starship. But for missions that require precision timing or ultra-sensitive cargo, Dream Chaser might be the perfect fit. And let's be real, NASA and the Department of Defense wouldn't be investing big bucks if they didn't see the potential. So what do you think? Is Dream Chaser the next big thing in space tech? Drop your thoughts in the comments. I'd love to hear your take. Anyway, if you loved this deep dive, smash that like button, hit subscribe, and ring the bell. We're aiming for 150,000 subscribers, and we need you to get there. Check out our other videos on Starship, Artemis, and more, and let's keep exploring the cosmos together. Dream Chaser is great, but is there a confirmed launch date yet? That question has been echoing through the space community for years. Enthusiasts and experts alike have been eagerly awaiting its debut. Yet we're still waiting. Back in 2020, Steve Lindsay, SNC's Vice President of Space Exploration Systems, was confident that Dream Chaser would launch in 2021. Fast forward 4 years, and it's still Earthbound. The first cargo variant, fittingly named Tenacity, is currently undergoing final tests at NASA facilities. The new target, no earlier than the third quarter of 2025. So, what's caused all the delays? Launch logistics. Dream Chaser was originally slated to fly aboard ULA's Vulcan Centaur rocket, but ULA had to prioritize getting Vulcan certified for vital U.S. Space Force missions. As a result, Dream Chaser was bumped in favor of dummy payloads. While there's a potential launch window for Tenacity in late 2025, nothing is locked in. ULA is currently juggling a dense queue of military launches, putting that 2025 timeline in jeopardy. SNC did consider a backup plan, the reliable Atlas V. But there's a catch. ULA stopped producing Atlas V in 2024, and only 14 launches remain to fulfill existing commitments, including Boeing's Starliner and other high-priority government missions. Dream Chaser getting one of those slots? Not likely. Another reason for this delay might be the technical hurdles. Dream Chaser uses landing gear for runway landings, similar to how NASA's Space Shuttle operated. The shuttle had 3 sets of landing gear that extended through doors in the heat shield. To save weight, these gears couldn't retract once deployed. And because extending them too early would compromise the heat shield, a potentially fatal flaw, they could only be deployed manually with no backup automatic system. Landing the shuttle was a high-stakes operation. It approached the runway at high speed, and once committed to land, there was no turning back. The landing gear had to work perfectly on the first try. Failure was not an option. So what if the shuttle's landing gear failed to deploy? In short, disaster. The orbiter wasn't structurally designed to survive a belly landing. If the cargo bay were empty, there might have been a slim chance for the crew. But if it were carrying payloads, the cargo could slam forward into the crew compartment on impact, likely resulting in tragedy. Now, Sierra Space is hoping to overcome these same risks. Adapting a legacy design like the Space Shuttle for modern use in Dream Chaser is a massive engineering challenge. Just look at the development timeline for their first flight-ready prototype, Tenacity. On June 16th, United Launch Alliance CEO Tory Bruno announced that the Atlas V launch for Amazon's Project Kuiper 2 has been delayed due to an unresolved issue with the nitrogen purge line. Now, if Bruno had posted this update on X as usual instead of Bluesky, it probably wouldn't have raised many eyebrows. But the fact that it came through Blue Sky is significant, especially because his X account was reportedly compromised just 4 days prior. Naturally, the internet had thoughts. Tweets like, "Imagine if there's a rocket launch involved," or "Imagine if the hacker tweets Raptor 3 is the greatest engine ever," started making the rounds. And honestly, they weren't far-fetched. In fact, SpaceX and ULA have a long and rocky history. Flashback to September 2016. A Falcon 9 rocket exploded during a routine pre-launch test. Elon Musk, never one to hold back, floated the idea that it might have been sabotage, suggesting that someone could have fired a shot from the rooftop of a nearby ULA building, which was about a mile from the pad. While the investigation ruled out foul play, it underscored the fierce rivalry brewing between SpaceX and ULA, one a legacy company and the other representing the new kid on the block with ambitions to dominate the rocket industry. Fast forward to July 2021. Musk responded to Tory Bruno with a not-so-subtle jab. ULA would be dead as a doornail without the two-launch provider DoD requirement. If this is not true, then you won't have a problem removing it. Your parent company, Lockheed, darkened the skies with lobbyists to ensure F-35 was single source. Seems a little inconsistent. Of course, Bruno couldn't stay silent. In August 2024, he publicly questioned the authenticity of SpaceX's Raptor 3 engine photos, calling them partially assembled. SpaceX executive Gwynne Shotwell clapped back almost immediately. Works pretty good for a partially assembled engine. And the drama didn't end on social media. In July 2024, ULA teamed up with Blue Origin to formally raise environmental concerns with the FAA, targeting SpaceX's ambitious plan to conduct 44 launches per year from Kennedy Space Center. While ULA was busy filing complaints, SpaceX was racking up milestones. Their Falcon rocket just completed its 500th launch, a mind-blowing feat in the world of rocketry. Meanwhile, ULA found itself struggling to keep pace. Years of operating without fierce competition dulled its edge. SpaceX, with its game-changing reusable rockets and lower costs, surged ahead. ULA's response was to develop the Vulcan rocket, a more cost-effective next-gen launcher. But that pivot came too late and too slowly. Even worse, ULA's delays started frustrating its most important customer, the Pentagon. In 2024, the company was slapped with financial penalties for failing to launch two key military satellites on time. And in 2025, the military is still voicing concerns about a growing backlog, more than 24 national security missions waiting to get off the ground. As a result, the U.S. Air Force has become increasingly reliant on SpaceX to deliver its most critical satellites into orbit using Falcon 9 and Falcon Heavy. Perhaps the ULA's biggest issue now is logistics, and it's starting to affect more than just its government contracts. Take Sierra Space, for example. Its Dream Chaser spaceplane was originally slated to ride atop Vulcan's second launch. But ULA prioritized military certification instead, pushing Sierra's launch back. May 2025 came and went, and still no launch. Neither ULA nor Sierra Space has addressed the delay publicly, which only deepens the concerns rippling through the space industry. So, when will Dream Chaser finally fly? With ULA still struggling to meet its military launch commitments, the answer might not come anytime soon. Don't be surprised if the mini space shuttle's debut slips into 2026, or even later. This isn't great news. Sierra Space holds a commercial resupply services contract with NASA to deliver cargo to the International Space Station using its Dream Chaser spaceplane and the Shooting Star cargo module. They're also working with Blue Origin to develop Orbital Reef, a privately owned space station in low Earth orbit. On top of that, NASA is hoping to find a backup to SpaceX's Crew Dragon. All of these ambitions hinge heavily on Dream Chaser's first launch, which will deliver crucial real-world data for future improvements. Real reliability often comes from multiple launches, so any delay in the first flight only pushes everything else further down the road. The development of the spaceplane takes a long time, so anxiety in both Sierra and the space community is only mounting. Right now, many are hoping Sierra Space will pivot, perhaps to a new launch partner, like SpaceX. Beyond just SpaceX vehicles' availability, there's another issue: ULA may not be the safest long-term option. ULA recently introduced a plan called SMART, Sensible Modular Autonomous Return Technology, aimed at saving money by reusing costly rocket parts. Their idea involves inflatable heat shields to protect the engines during re-entry, followed by ocean splashdowns using parachutes. ULA claims this could cut engine costs by up to 90%. But here's the thing, they started this way too late. SpaceX began testing reusability in 2012 with its Grasshopper prototype. By the time ULA launched SMART, SpaceX had already mastered Falcon 9 landings, slashing costs by 65% per launch. In such a fast-moving industry, ULA's late entry puts them at a disadvantage. It's like showing up to a race when the competition is already halfway to the finish line. With these struggles, ULA still faces the looming threat of being sold off by its parent companies. That puts Sierra Space at risk of losing its launch access entirely. Also, Tory's stance on reusability quietly goes against today's prevailing opinion. He once remarked, "You won't believe me, but reusability isn't that much cheaper." That viewpoint doesn't sit well with many modern rocket entrepreneurs. Take Andy Lapsa and Tom Feldman, co-founders of Stoke Space. They firmly believe that the future of space travel lies in rockets that are fully and rapidly reusable, capable of flying with the same frequency and efficiency as commercial aircraft. They view today's partially reusable rockets as just a stepping stone, warning that any launch system not built for full rapid reuse will soon be left behind. The economics of rapid reusability are central to their philosophy. The two biggest cost drivers in space launch are rocket manufacturing and the fixed costs of infrastructure, things like factories, testing facilities, launch pads, and labor. Reusability slashes the need for new manufacturing and allows those fixed costs to be spread across many more launches, cutting the cost per flight dramatically. With high launch frequency and full reusability, costs could plummet from thousands of dollars per kilogram to just a few hundred, similar to how airlines operate today. And it's not just about saving money. Full reusability also boosts availability and reliability. Right now, launch lead times often exceed 18 months, which limits how businesses can use space. Reusable rockets allow for more frequent launches and improved dependability. SpaceX has already demonstrated this with its first-stage boosters, which have a near-perfect track record compared to expendable upper stages. Stoke's goal is to create rockets that are not only fully reusable, but also quick to turn around and highly reliable, solving the three biggest challenges in modern spaceflight. The timing couldn't be more critical. Satellite tech has advanced significantly. Today's satellites are smaller, cheaper, and deployed in larger numbers. As a result, launch costs have become the biggest expense in putting them into orbit. Reducing those costs and improving availability would unlock a wave of new commercial and government opportunities, powering a truly scalable space economy. Anyway, if you loved this deep dive, smash that like button, hit subscribe, and ring the bell. We're aiming for 150,000 subscribers, and we need you to get there. Check out our other videos on Starship, Artemis, and more, and let's keep exploring the cosmos together. Still, switching from ULA to SpaceX isn't easy. Sierra has binding contracts with ULA to use the Vulcan Centaur for 7 NASA cargo missions. These deals are deeply tied to ULA's infrastructure and launch cadence. Breaking away would mean renegotiating everything, possibly leading to costly penalties or further delays. ULA, a joint venture between Boeing and Lockheed Martin, has long-standing ties with the U.S. government, including the Space Force. That's part of why Sierra Space partnered with ULA in the first place. It's like having a government-backed ally in the business. On the other hand, SpaceX, led by Elon Musk, is wildly successful and launches more rockets than anyone. But Elon's controversial comments sometimes ruffle feathers in Washington, D.C., making SpaceX feel like a bit of an outsider. That's why Sierra Space might see ULA as a safer choice politically, even though SpaceX is outperforming everyone. Also, switching would come with strategic baggage. ULA and SpaceX are fierce competitors. Vulcan is meant to rival Falcon 9. A shift to SpaceX could look like betrayal and potentially damage Sierra Space's relationships with Lockheed and Boeing, both heavily invested in ULA's survival. There are technical hurdles too. Dream Chaser's design, with its 15-foot cargo module, was tailored for Vulcan's lift capacity, 27,500 kilograms to low Earth orbit. Falcon 9 maxes out at 22,800 kilograms, while Falcon Heavy can handle 63,800 kilograms. Moving to SpaceX would require engineering tweaks for fit and re-entry, which means added cost and time. Plus, with SpaceX prioritizing its own Dragon spacecraft, Dream Chaser might get less flexibility as a third-party payload. That said, a shift isn't out of the question. If ULA's delays drag on past 2025 due to more government demands or technical Vulcan issues, Sierra might seriously consider SpaceX as a backup. Some even speculate that Sierra could acquire ULA, weakening the current partnership and clearing a path to Musk's company. And with Falcon 9's lower price tag of $67 million per launch versus Vulcan's estimated over $100 million, money could ultimately tip the scales, assuming Sierra's contracts allow for such a pivot. On June 15th, media outlets captured images of Starship 36 rolling out for static fire testing at SpaceX's Massey test site. Unlike its predecessors, like S-33 and S-34, which had missing heat shield tiles either at the top or bottom, S-36 appears to sport a full complement of these critical thermal protection components. This points to a shift in SpaceX's approach, potentially emphasizing greater durability and a safer re-entry profile over pushing performance limits, as seen with earlier models. Another notable change is the increased use of gap fillers between the heat shield's hexagonal tiles. These fillers are crucial during re-entry, where temperatures can soar above 1,650 Kelvin, 2,510 degrees Fahrenheit, or 1,377 degrees Celsius. In such extreme conditions, hot gases can seep through the narrow spaces between tiles. Gap fillers act as a second line of defense, insulating the vehicle's structure from intense heat and minimizing the risk of damage. However, we still don't know the exact type of gap filler being used. What we do know, thanks to Elon Musk's comments to Ars Technica ahead of Flight 9, is that SpaceX has varied the gap filler. This change was tested alongside other updates to the heat shield, including new coatings, fabrication methods, and attachment techniques. The early results are promising. Elon mentioned there was no significant loss of heat shield tiles during ascent, and noted they've gathered a lot of good data to review. That data is absolutely essential. The critical phase, high-speed atmospheric re-entry, generates heat and stress levels that simply can't be simulated on the ground. Real flight data gives engineers the insights they need to improve tile performance and overall vehicle safety. Interestingly, there's also a central horizontal section on S-36, where tiles are missing, revealing the structural underpinnings. You can see metal brackets or supports in that exposed section, with clips or protrusions that might be used to anchor tiles or gap fillers. Some tiles on the edges seem to be loose or misaligned, suggesting assembly or repair work is still underway. Additionally, white thermal felts are visible in multiple areas. These materials, cut into hexagonal shapes and tucked between tiles. They serve as a secondary insulation layer, enhancing the spacecraft's heat resistance during re-entry. This process is significantly simpler and cleaner compared to using room temperature vulcanizing, RTV, silicone, which was utilized on NASA's Space Shuttle and Sierra Space's Dream Chaser. Both methods serve a similar purpose, sealing gaps and providing insulation. RTV functions as a secondary sealant between tiles, filling small spaces to block hot gas from penetrating during re-entry. Although it's not the main thermal barrier, it plays a role in maintaining structural integrity. In contrast, the white felt observed on S-36 likely serves the same function, sealing gaps and offering added thermal protection, but it's applied through a much more straightforward, hands-on method that requires little more than precision tools. RTV silicone, on the other hand, requires mixing a base compound with a curing agent, typically in a 1 to 5% ratio, and cures at room temperature with moisture. It's applied as a paste or liquid, which then hardens under controlled environmental conditions, such as humidity and temperature. This makes the process more complex, with careful attention needed to prevent uneven distribution or excess material, issues that can arise even in industries like automotive gasket manufacturing. From a cleanliness standpoint, the white felt seen on S-36 looks exceptionally tidy. Its pre-cut hexagonal shape and careful folding result in clean edges with no visible residue or overflow. Being a dry material, it doesn't drip or smear, eliminating the need for cleanup after installation. This makes it a much cleaner alternative to RTV. RTV, being liquid during application, is inherently messier. Excess material often squeezes out, requiring trimming or wiping once cured. Moreover, its chemical nature introduces risks like outgassing or poor adhesion, if not applied perfectly, challenges that are less than ideal for high-stakes aerospace environments like Starship. In terms of thermal and mechanical performance, if the white felt is made from ceramic or carbon-based fibers, common in aerospace, it likely withstands temperatures between 1,200 degrees Celsius and 1,400 degrees Celsius. While this is slightly below the 1,650 Kelvin, 1,377 degrees Celsius, temperatures the tiles endure. Their flexibility and ability to conform to gaps help reduce stress points, those spots where the spaceship might crack or break under pressure. Imagine squeezing a soft cushion into the cracks of a Lego structure to keep it steady. That's kind of what the felt does. RTV silicone, while flexible and adhesive, offers heat resistance typically up to 205 degrees Celsius, 400 degrees Fahrenheit, with some specialized formulations going higher. However, that's still far below the heat levels of atmospheric re-entry. As a result, RTV likely sees limited use in Starship's heat protection system, restricted to less demanding secondary areas. It also degrades more easily when exposed to plasma, making it less viable as a primary gap filler. Considering Starship's core mission, rapid reusability and streamlined maintenance, the advantages of white felt become clear. If the material is replaceable, it could speed up post-flight repairs. RTV, by contrast, must be reapplied after damage, involving a curing process that takes hours to days, depending on conditions. Elon Musk has pointed out how time-consuming tile maintenance was on the space shuttle, a problem SpaceX clearly wants to avoid. Finally, ceramic felt could be cheaper and easier to mass-produce than custom RTV compounds, especially if SpaceX standardizes an in-house production method. The manual placement, seen on S-36, suggests a low-tech but scalable strategy that fits well with initial testing phases. While RTV is commercially available, its use in aerospace requires strict quality control, increasing costs. It also needs skilled technicians and specialized tools, factors that make it harder to scale for large surfaces like Starship's belly. In summary, the felt's foldable, pre-cut design sidesteps RTV's mess and curing time, offering a pragmatic solution to the reusability challenge. This low-complexity approach might be a deliberate choice for S-36's static fire test, allowing SpaceX to quickly validate its effectiveness without the additional complexity of RTV application. Anyway, if you loved this deep dive, smash that like button, hit subscribe, and ring the bell. We're aiming for 150,000 subscribers, and we need you to get there. Check out our other videos on Starship, Artemis, and more, and let's keep exploring the cosmos together. It's fair to say that in pursuit of full and rapid reusability, SpaceX has implemented some of the most advanced thermal protection system technologies ever developed for Starship. This system is more intricate than those found on other spacecraft, like Sierra Space's Dream Chaser, which makes sense given Starship's larger size and far more ambitious goals. Dream Chaser, a reusable winged spaceplane about 30 feet long, is built for low Earth orbit missions. Its primary role is to deliver cargo to the International Space Station under NASA's Commercial Resupply Services contract, with future potential for carrying crew. Starship, by contrast, is a fully reusable spacecraft standing roughly 403 feet tall. It's designed not just for LEO missions, but for interplanetary journeys, like to Mars, lunar landings, and heavy-lift orbital transport. Dream Chaser's thermal protection relies on upgraded tiles made from a silicon carbide and carbon fiber composite. This silicon carbide-based TPS combines the high heat resistance and corrosion durability of silicon carbide with the strength and thermal consistency of carbon fiber. The result is a lightweight, low-profile barrier that maintains insulation and aerodynamic stability during multiple re-entries. Covering most of the vehicle's exterior, these advanced tiles are similar to the Space Shuttle's TPS, but with updated coatings. Notably, Dream Chaser uses larger 10 by 10 inch tiles compared to the Shuttle's 6 by 6 inch versions, meaning only about 2,000 tiles are needed instead of the Shuttle's 24,000. Another material, toughened Uni-Piece. Fibrous reinforced oxidation-resistant composite is used on Dream Chaser's most heat-exposed areas, such as the nose and wing edges. This material, which has also flown on the X-37B, replaces the Shuttle's reinforced carbon-carbon and offers improved toughness and affordability. Starship, on the other hand, features around 18,000 ceramic hexagonal tiles across its windward side. These are produced in-house by SpaceX and are likely made from silica or alumina-based materials designed to withstand high heat flux. Underneath the tiles lies the 304L stainless steel airframe, which acts as a heatsink. With a melting point around 1,400 degrees Celsius, this stainless steel allows for thinner tiles and provides resilience to minor damage. Unlike the Shuttle's aluminum frame, which was more vulnerable to heat. To survive superorbital re-entries, like those from Mars, Starship might employ active cooling systems using liquid methane. These could include heat pipes or film cooling, where methane is expelled across the surface to create a protective barrier layer. These upgrades have been incorporated into recent tests as SpaceX sharpens its focus on rapid reusability. In parallel, early Mars missions might still rely on ablative materials for the vehicle's leading edges or high heat zones, trading reusability for increased payload capacity. As said, Starship's tiles are mechanically fastened, not bonded like those on the Shuttle or Dream Chaser. This enables easier replacement and speeds up maintenance, critical for fast turnaround between flights. The vehicle's reflective stainless steel skin has low emissivity, reducing how much heat it absorbs, but does require active cooling during re-entry. Starship's TPS is engineered for extreme dynamic pressure and heat during belly-first re-entry, ideal for interplanetary travel. The steel's heat-sinking properties reduce the dependency on perfect tile coverage, which was a necessity on the Shuttle's less heat-tolerant aluminum structure. Compared to NASA's Space Shuttle, Dream Chaser also uses room-temperature vulcanizing silicone to help secure its tiles and prevent them from coming loose. However, it skips thermal blankets, unlike the Shuttle, making the system simpler and more tile-focused. Its TPS is capable of withstanding temperatures up to 1,650 degrees Celsius, 3,000 degrees Fahrenheit, and helps regulate internal temperatures during orbital sunlight exposure, around 250 degrees Fahrenheit. All these improvements make Dream Chaser's tiles stronger, lighter, and more cost-effective than those used on the Shuttle. Modern coatings lower costs without compromising thermal performance. Larger tile sizes reduce maintenance demands and meet micrometeoroid and orbital debris protection standards. Materials like TUFROC and silicon carbide composites offer added resilience in critical heat zones. That said, tile-based TPS systems still require regular inspection and potential tile replacement. But thanks to the stronger, larger tiles and shielding provided by fairings, Dream Chaser's maintenance burden is far lighter than what the shuttle faced, and is sufficient for the less extreme conditions of LEO re-entry. More advanced than Sierra Space's approach, SpaceX uses mechanically attached tiles to simplify maintenance and replacement, directly tackling the labor-intensive challenges faced by the Space Shuttle's TPS. The stainless steel airframe adds structural resilience, allowing the vehicle to survive even if a few tiles are lost during flight, which would have been catastrophic on the shuttle. If implemented, active cooling systems could further boost heat management during extreme re-entry scenarios, a key enabler for future Mars missions. Producing tiles in-house also gives SpaceX greater control over the supply chain and makes the system more scalable. Naturally, these innovations come with challenges. Active cooling adds system complexity, increasing the difficulty of manufacturing and introducing more potential points of failure. The high tile count, around 18,000, necessitates a strong quality control and inspection regime, though this is less burdensome than the shuttle's system, thanks to the mechanical attachment method. And if ablative thermal protection is used on early Mars missions, it would reduce the reusability of the vehicle, trading longevity for survivability in